Traffic congestion problem has constantly intensified in Bangkok metropolis, the capital city of Thailand, where more than 10 million people live and conduct their businesses. The city also serves as the national economic center. To resolve such problem, as well as to enhance the potentials in the metropolitan development to be equivalent with other capital cities around the world, the Bangkok Metropolitan Administration initiated the development of mass rapid transit system in Bangkok. In 1999, the first mass rapid transit system of Thailand was operated on the Silom and Sukhumvit lines, with a total distance of 23.5 kilometers. The lines continuously serve people and facilitate the travels of Bangkok residents for more than 10 years. Later in 2009, the Bangkok Metropolitan Administration launched an extension of mass rapid transit system to link up both sides of the city on the Chao Phraya River, on the Silom line from Taksin Bridge to Taksin Road, a distance of 2.2 kilometers, enabling Bangkok residents to travel across the river more convenient and faster. On 12th August 2011, the BMA successfully started the mass rapid transit system on the extension of Sukhumvit line from Onnut to Bering, the connecting point with Samut Prakan province, and became the first mass transit service to link up with the city suburbs on the east, enabling the travel from the perimeter to central Bangkok to be more convenient and faster. The mass transit service became more extensive, with 5 new stations added. Starting from Bangkok Station at Soi Sukhumvit 97, in front of the Bangkok College, along Sukhumvit Road to Punawiti Station, and further to Udom Suk Station, passing Bang Na intersection to Bang Na Station in front of the Meteorological Department, near Bitek International Trade and Exhibition Center, and ending at Bering Station, located between Soi Sukhumvit 105 or Soi La Salle and Soi Sukhumvit 107 or Soi Bering. The extension covers the entire distance of 5.25 kilometers. On the 20th of July 2006, BMA awarded the contract to Italian Thai Development Public Company Limited to construct the civil and track works. Later, on the 2nd of July 2010, Italian Thai Development Public Company Limited was again entrusted by BMA to design, procure, install, test and commission railway electrical and mechanical systems. The railway systems in this project comprises 4 main systems, such as 1. Signalling system, 2. Communication system, 3. SCADA system, 4. Power supply system, All these main systems provide a functional, safe, accurate and efficient train operation. The signaling system is the heart of the train operating system, controlling the trains to move automatically with maximum safety for passengers. The system controls the trains to run safely in all conditions, prevents any accidents, and keeps the trains at the speed which suits track conditions and in line with train schedules. Moreover, it controls the opening and closing of doors, the parking of the trains at the station, include managing train operations to suit each period, both during peak hours and normal hours each day, by taking into account the appropriate headway of each train as specified. The signaling system installed in the mass transit railway extension is based on CBTC, or Communication-Based Train Control Technology, which controls and commands the operation between the control center and the trains through the wireless data network. With the Belize equipment installed throughout the route to transmit physical data to the passing trains, so that the data are processed by onboard computers and the data are sent through the radio transmission network to the interlocking equipment at the station and the central traffic control at the Operation Control Center, where the train operation commands are transmitted back to the trains and to control equipment along the track, such as the point machine and point-locked indicator, to be in harmony with the movement of the trains. All operations proceed automatically. Apart from the signaling system, which is the main function controlling train operations, there is also the power supply system, which distributes power to the trains and the stations. The system has been designed with maximum stability from two 40 megawatt generators dedicated for the extension. The bearing substation is the main source of power distribution, and the Samrong exchange as an alternative source working on a hot standby basis, ready to distribute power in a split of a second in case the main source fails. Problems so that the train operation would not be impacted. Both sources distribute power at the voltage of 24 kV to the receiving service at bearing station, and further distribute to the trains by the traction service substation, then distribute to the stations through the station service substation. Power to be distributed to the trains through the traction service substation would be sent through the traction transformer and rectifier, so that the voltage will be converted from the alternating current at 24 kV to direct current at 750 volts and further transmitted to DC switchgear equipment, third rail and the trains respectively. Moreover, this project has an emergency diesel generator, which is ready to distribute reserved power to the station and major control system to accommodate service operation in emergency, with a reserved oil tank for generating power up to 8 hours and can be operated continuously for 7 days if necessary. There is also the uninterruptible power supply, or UPS, to continuously distribute power to major control equipments in case of blackout, before the emergency diesel generator takes over the task. The equipment is designed to distribute reserved power for 30 minutes. The communication system is one of the main systems supporting the transmission of various datas in train operation control and being the tool to help support train operation and maintenance. The communication system is divided into 6 subsystems, such as: first, the backbone transmission network as the center of data transmission and the linkage of various systems through 24 cores optic fiber network from the station to the operation control center, which were designed as a duplicated ring circuit for stability and reliability of the system. Second subsystem, the telephone system for communication in the train operation and maintenance at the operation control center, stations and the maintenance centers. Third subsystem is the radio communication system, which facilitates the officers in communicating during train operation, both in normal and emergency cases, as well as in maintenance. Hand-portable radio is used in radio communication system. The signals transmitted through the leaky cable installed along the track and at concourse level of each station, conceding to the base station equipments at E10, E12 and E14 stations. The fourth subsystem is the public address system, used for announcements from the OCC or station control room, and also the announcing points which microphones are installed on both platforms, as another channel to inform news and information to the passengers. The system has a function which links to the fire alarm system to announce the automatic preset statements. To make the announcement heard in the entire station area, the project has set up 150 speakers per station, equipped with sensing microphones to measure surrounding noises and automatically adjust the sound from the speakers accordingly. And for passengers' maximum safety, in the use of the service, more than 50 CCTV has been installed per one station for secure and support train operation. CCTV camera covers the entire area of the station, from road level, concourse level, to platform level, so that officials in the station and those at the operation control center are able to observe the stations and make decisions in efficiency, commanding and controlling service operation in various situations. CCTV were linked with the emergency system of the signaling system. In emergency cases on the platform, the scenes will be automatically displayed on the screen at the control room of the station. And to make all systems work in harmony, a master clock system has been set up as reference for all systems, so that all of them work in correspondence with each other efficiently. As the mass transit system covers long distances, the Supervisory Control and Data Acquisition or SCADA system has been put in use. This system helps the train operation management and maintenance by following up and recording the working status of various equipment. Moreover, it has an ability to control the power distribution to the trains and the stations during the normal operation and emergency case. The follow-up and control of status are made through SCADA computer system at the Operation Control Center by the specific program which was developed to link signals to 2,300 points of equipments in 5 stations. From all those aforesaid, it is fair to believe that the extension of Bangkok Mass Transit System project on Sukhumvit Line, Onnut to Bering, would be the route to revolutionize the mode of travel of Bangkok residents on the east as well as residents of Samut Prakan in order to reach the heart of the Bangkok city with more convenience, speed and accuracy, leading contribution to economic opportunities, creating income and bringing prosperity to the area. Besides, reduce pollution, conserve the environment and return warmth and happiness to families. Create a better quality of life to the people of the Bangkok metropolis and the perimeters.